So, as we have seen, there are two types of functions, user-defined functions and built-in functions. We had seen certain built-in functions in the previous examples like max, min, sum, and then again we have seen some functions like print and cat. So we saw that print can print a value, but cat can also print the text, the caption, comma, the value, new line, etc. So we are now heading towards our own user-defined functions, that how we can create functions. So in this example, you will see a simple R function is to check whether x is even or x is odd. So how we go about it? Let's have a look on the function. I have taken a variable even odd, which is equal to function x. Now what is this x? This x is a value that I'm passing as a variable. Now in the function I'm writing if x is %%2, which means if I divide x by 2 and the remainder is 0, return even, otherwise return odd. So this is my little function which is just applying a modulo operator and trying to find out whether the remainder is 0 or not. So if the remainder is 0, the number is even, and the remainder is non-zero, then it is an odd number. So I am printing even odd. Okay, and what I'm doing over here, I'm printing even odd, and you can see the output on the screen. For the first print command, the output is even, and for the second print command, the output is odd. So that is how we are calling the even odd function within the print function with a value, and that value is substituted to the x variable. So whatever value I am passing within the even odd function, that value replaces the x, and that value is divided by 2, and respectively either even is printed as an output or odd is printed as an output. Now next we will understand what are the coercion rules. What is this concept of coercion rule? So basically coercion rule is nothing but a concept where we are trying to save the data. So if logical values are there, they are converted into numbers. For example, true is converted to 1 and false is converted to 0. Values are converted to the simplest type required to represent all information. So if I'm representing the entire information, I am converting the data into the simplest type. And the ordering is roughly logical to integer, integer to numeric, numeric to complex, complex to character, and character to list. So that is how we are ordering the data. Now understand the concept of difference between conversion, coercion, and cast. That what is the difference between these three words? Now whatever is converted implicitly is referred to as coercion. But if converted explicitly, then it is called as casting. So that is the difference between conversion, coercion, and casting. So mainly, automatically if it is done, then it is coercion. But if I am doing it explicitly, then I am calling it casting. Let's take one example of coercion rule and understand better. So basically, coercion of an object from one type of class to another is known as explicit coercion. Explicit coercion to character has some features. There are two functions, so like as.character and as.string. So these are the two functions which are used for explicit coercion. If v is a vector which is needed to be converted into character, then it can be converted as.character and within brackets v. I'm writing encoding equals to null. Encoding is a property which is equated to null by default. Likewise, I am using as.string function, and there I am passing v as a vector. So two functions are as.character and as.string. Now in the example you can see I have created a list with the C function where I write 0, 1, 0, 3. So it is a list, and that list has been assigned to a variable x. Now I am writing a command as.character. So what I am doing over here, I am converting it to character type. So now my value was 0, 1, 0, 3. was a numeric value. It was a numeric value which was a list, and now I want to convert that into a character data type. So what I'm doing over here, I'm using as character function and I'm passing x as my variable. So that is, I'm doing a coercion, and this is called as the explicit coercion to character. So how does R coerce data types? This is a big question, that how it coerces the data types. So if a character string is present in an atomic vector, R will convert everything else in the vector to character string. So if supposingly I'm coercing, in that case there are multiple values, different data types are there. Okay, and that then there is a character string is also present in that particular vector. So it will convert every element in the vector to character string data type, which means character will override the rest of the data types. If a vector only contains logical and numbers, now take example of a vector where there are just numbers and logical values like true or false. So R will convert the logical to numbers. So in that case, true will become 1 and false will become 0, which means if I have true, comma 1, comma 0, comma 1, comma 0, like that. So in that case, true will be automatically converted to 1 and false will be converted to 0. So if I see all the values in totality in a particular vector, I will find that different values, all the if different types of data types are present, for example logical and numbers, then everything will be converted to numbers and it will save the logical data and convert that into 1 and 0. So you can see over here R uses the same coercion rule when you want to do maths with logical values. Let's have a case of this code and see what happens. If I say sum of C, true, true, false, false. So here what I'm doing, I am finding out the sum of the function 1, 1, 0, 0. So you can see over here it has added 1, 1, 0 and 0. So that is how it is working. So which means true has been converted to 1, the second true has been converted to 1, and then the third value is false, which is converted to 0. Fourth value is false, which is again converted to 0. And you can see over here that 1, 1, 0, 0 is calculated, and that particular value is becomes your this will become your output input for the sum function, because logic for the logical values like true, false, we cannot have a sum function. So automatically the coercing of the data takes place in order to save the data. So what will be the outputs? We will come to know how many trues are there. If suppose, let's take the case that how many defaulters are there. Are you a defaulter? Yes, true. Are you a defaulter? No, false. So if you are a defaulter, it converts into 1. And how many defaulters in the list? I find out the sum of C. So I come to know, suppose the sum becomes 34, which means 34 defaulters. So that is how we start converting the data with the help of coercive rules, following the coercive rules, and then we can find out certain statistics of the data. Packages. Now let's understand the concept of packages. What are packages in R? R packages are collection of R functions, compiled codes and sample data. So basically you will say, what is the difference between a library and a package? That is very important for us. So in a package we have functions, we have the compiled code, that is the complete code which is compiled, and some sample data on which that function is running. So they are stored under a directory called library in the R environment. So mainly in the R environment, there is a directory which is called as library, and there you will get all the packages which are available in R. So by default, R installs a set of packages during installation. R will install lot of packages during installation. When we start the R console, only the default packages are available by default. So basically, we have the default packages which are installed automatically when we start our console. Now, let's understand what are repositories. A repository is a place where packages are located and stored so you can install packages from it. So basically, repository is a place where the packages are residing. Organizations and developers have a local repository. Typically, they are online and accessible to everyone. So we can say that the repositories are available online. It is very much like they have supplied you lot of packages which are online available. Okay, and then accessible to everyone. Open source means freely available. You have to only incorporate that in your program. So let's understand CRAN. What is CRAN? CRAN is Comprehensive R Archive Network. It is the official repository. It is a network of FTPs, which is File Transfer Protocol, and web servers maintained by the R community around the world. So basically, this is the official repository of R, and it is maintained around the world, which means it is globally present and anyone can access it. The R community coordinates it, and for a package to be published in CRAN, suppose I want to publish a package in CRAN, the package needs to pass several tests to ensure that the package is following CRAN policies. So this is quite a huge task. Suppose I want to write a package for R and I want to publish it in CRAN. Then my package will pass, it will be tested and verified, and only then the package will be going as per the CRN policies into the CRAN, which is the Comprehensive R Archive Network, which is the official repository of R. Next, we have bioconductors. Bioconductor is a topic-specific repository intended for open source software for bioinformatics. So basically, it is a topic-based repository. It is open source and for bioinformatics. Similar to CRAN, it has own submission and review processes, and its community is very active, having several conferences and meetings per year in order to maintain the quality. So again, if I want to submit a package in bioconductor, my package will go a rigorous screening, and only then I will be if I meet their quality, my content or my package meet their quality, only then it will be published under bioconductor. Likewise, there is a package called as GitHub. So GitHub is the most popular repository. It is a repository for open source projects. Open source project means when I am designing a project and it is freely available. It is popular as it comes from the unlimited space for open source, the integration with Git, a version control software, and its ease to share and collaborate with others. So basically, again, Git Hub is also an open source repository where I can publish my packages. But again, the screening process is quite difficult and quite tough. And if I meet their qualities only, then I can publish my packages into their repositories.